Hello there guys, and welcome to the channel. Over the last couple of years I have accumulated a substantial quantity of Intel Pentium Pro CPUs in various speeds and cache configurations. In this video we shall be taking a look at 3 of my 200MHz Intel Pentium Pro CPUs, testing and where necessary attempting to repair their bent pins. The Intel Pentium Pro is my all-time favourite processor in the lovely gold and purple ceramic package. The gold being the main reason that this processor is still very popular, for the extraction of the gold that they contain, which obviously destroys the processor. In hand, the Intel Pentium Pro certainly is a truly hefty processor, weighing around 60 to 70 grams, approximately 2 to 2.5 ounces, and of which around the time that this processor would have been in servers all over the world, I was completely unaware that they existed. There are 5 variations of the Intel Pentium Pro ranging from 150 to 200MHz in the lovely gold and purple ceramic package. The 150, 180 and 200MHz CPUs have 256KB level 2 on-chip caches, with the 166MHz variant having a 512KB level 2 on-chip cache. The 200MHz variant is the only CPU that comes in both 256KB and 512KB versions. I'm pleased to say that I have an example of all 5 speed and cache variants in my collection. The test bench that we're going to be using is a Baby AT Socket 8 TMC RESEARCH CORPORATION AI6NF motherboard running at the Intel 440FX Natoma chipset and supports Intel Pentium Pro CPUs from 150MHz to 200MHz with an external bus speed of 60 or 66MHz. There are 4 32-bit PCI slots, 4 16-bit ISA slots, 1 floppy drive interface, 2 ID interfaces, parallel port, AT keyboard connector, PS2 mouse interface, 2 serial ports, an infrared connector, a VRM connector, and USB connector. The first Intel Pentium Pro we'll be testing is the SY032 with a 256KB level 2 on-chip cache. The graphics card we're going to be using is an ATI Graphics Expression Max 64 CT with 1MB of video memory. For memory we have 96MB of EDO sims, and the boot device we'll be using is an IDE to compact flash adapter with a 2GB Hitachi microdrive as the boot drive. Right then, let's get a little desk rig together then, and we'll see how we get on. Unfortunately, I do not have the voltage regulator module. Running an Intel Pentium Pro without a voltage regulator module or VRM is not recommended and could potentially damage the CPU. The voltage regulator is responsible for supplying the appropriate voltage to the CPU to ensure it operates within its specified voltage range. Without proper voltage regulation, the CPU may be subject to voltage spikes or fluctuations, which can lead to overheating, instability, or even permanent damage to the processor. It's crucial to ensure that any CPU, including the Intel Pentium Pro, is powered with a stable and appropriate voltage to prevent damage and ensure reliable operation. If you're experiencing issues with voltage regulation, it's best to address them promptly to avoid any potential damage to your hardware. And on that basis, I wouldn't try this at home. As I have plenty of spare processors, I'm just going to ignore that strongly worded advice and we're just going to run with this setup anyway. To mitigate the risk of power spikes, it's essential to use a high quality power supply unit with stable voltage regulation. As we are running this setup 28 years into the future and we have much better quality power supply units available, this should mitigate some of the risk. Otherwise, this could end badly. Now before we can send some power through this motherboard, let us remove this anti-static bag from underneath, because we don't want to destroy this lovely piece of hardware. Now we can give her some juice, and hope that this is not going to damage the processor. Well, she is running. I'll just go into the BIOS to set up the root device, so that we can get into DOS and run a DOS bench. I'll run the same series of benchmarks on each CPU, 3D Bench 1.0 for faster PCs, PC Player benchmark in 640x480, the Quake Time Demo in 640x480, and we'll take a look at the statistics on Speedsys. 3D Bench 1.0 for faster PCs scores 87.8 FPS. PC player benchmark in 640x480 scores 15.1 frames per second. Doom on max detail for faster PCs, 2134 game ticks divided by 2041 real ticks times by 35 gives us approximately 36.59 frames per second. The Quake Time Demo in 640x480 scores 38.3 frames per second. In Speedsys, we can see that the processors in Intel Pentium Pro are 200 MHz with the codename P6. CPU caches, the level 1 cache is 16KB and the level 2 cache is 256KB. Speed via the TMC is 199.42 MHz, MMX no, and AI SSE no. Memory, we have EBO sims at 70 nanoseconds and we have 96 MB of memory available with a memory bandwidth of 165.37 MB per second. Video is an ATI graphics expression Max 64 CT with 1024 KB of memory. An Intel 82440FX Natoma chipset with an American Megatrends BIOS dated the 15th of the 7th 1995 and we are running DOS version 6.22. In the processor benchmark, I know you can't clearly see the score, but it is around where we're expecting, right on the line for P6-200. The results for the memory timing are as follows. The 8KB data cache level 1 transfers 702.05 MB per second. The 256KB data cache level 2 transfers 289.51 MB per second. And the memory throughput is 80.70 MB per second. And that nicely concludes the results to the first series of benchmarks. Now we'll remove the current CPU and move on to the next Pentium Pro, the SL22V. Another 200 MHz Pentium Pro with a 256KB level 2 on-chip cache. The CPU does not drop nicely into the socket, therefore there must be some bent pins. I'm going to attempt to repair the bent pins now on the CPU by simply using an old mobile phone top-up card just to run in between the pins. The thickness is near on perfect for the spacing to the pins. And after running the card through the pins in all directions a few times, we now have a CPU that fits nicely into the socket. Right, so I'm going to be doing the exact same benchmarks on the CPU, and there should be barely, if not zero, difference between these CPUs, as they are both 200MHz and both have a 256KB level 2 on-chip cache. And as expected, 3D Bench 1.0 for faster PCs scores 87.8 frames per second, which is exactly the same as the previous CPU. PC Player benchmark in 640x480 scores 15.1 frames per second, which is also exactly the same. The Quake Time Demo in 640x480 scores 38.2 frames per second, so a tiny difference, a loss of 0.1 frames per second, which is negligible. Now on to Speedsys, and in the processor benchmark score, we can see it's right where it should be, right on the P6-200. The results for the memory timings are as follows. The 8KB data cache level 1 transfers 702.05 MB per second. The 256KB data cache level 2 transfers 289.55 MB per second. And the memory throughput is 80.69 MB per second. And again, negligible difference. Slightly faster transfer speed on the level 2 cache by 0.04 MB per second and 0.01 MB slower on the overall memory throughput. Most people will now be just thinking that doing all of these benchmarks is just completely pointless, but the only reason is to simply test that these processors are still in good working order, and these benchmarks simply verify that. This is now the last CPU that we'll be testing in this video, the SL254. And this CPU fits nicely into the socket, no need for any repairs. I really do not like having to repair bent pins, then past a certain point they are more likely to completely snap off when attempting to restore them to their correct position. Off we go again then, and onto the final series of benchmarks. .3DBench 1.0 for faster PCs scores 87.8 frames per second, exactly the result of the previous two CPUs, which is excellent. PC player benchmark in 640x480 scores 15.1 frames per second, which again is the same result. The Quake Time Demo in 640x480 scores 38.3 frames per second, the same result as the first CPU. Now on to Speedsys, and the processor benchmark score bar is where it should be, right on the P6-200. The results for the memory timing are as follows. The 8KB data cache level 1 transfers 702.10 MB per second. The 256KB data cache level 2 transfers 289.55 MB per second. And the memory throughput is 80.69 MB per second. So those results are exactly around where we would be expecting them to be. very similar to the previous CPUs, which brings us neatly to the end of this video. Thankfully, all of the CPUs survived that test. I'm sure that I'll be revisiting the Intel Pentium Pro collection again at some point in the future. Until next time, take care guys.